We're going to look here at number 4, f of x equals x squared plus x minus 2, all over 4x plus 4. First thing we're going to do is factor both the numerator and the denominator if possible. So the numerator is quadratic. Looks like we can factor this into x plus 2 times x minus 1. And in the denominator, we can factor a 4 out of there. So that's going to be 4 times x plus 1. So that is complete. Next, we will look for the 4 different things that we consider. So that's wholes, zeros, which are x-intercepts, vertical asymptotes, and either horizontal asymptotes or slant asymptotes. So let's take a look at these 4 wholes. Step 2 here. We look for canceled factors. Well, nothing in the numerator cancels with anything in the denominator, so there are no wholes. Next, we look for zeros. Zeros are values that make the numerator equal 0. Well, if x were equal to -2, or x is equal to 1. So we are looking at the numerator here, values of x that make that equal 0, -2, and 1. So we're going to go ahead and put those points on our graph. So 0 at -2 and at 1. Next, we go to vertical asymptotes. Values that make the denominator equal 0. Well, if we look at our denominator, x equals -1 would make the denominator equal 0. So we'll go ahead and put a vertical asymptote at x equals -1. And now we will go ahead and look at horizontal or slant asymptotes. Here's where we look at the degree of the numerator and the degree of the denominator. And we're going to compare those. So the degree of the numerator, we can look back to our original. Before we factored, we can look at the factored because we just know that x is multiplied by x and we get an x squared. But looking at the original will always work. So we have x squared. So the degree of the numerator is 2. And the degree of the denominator is just 1. And so we look here at part A, B, and C. And we see that this is where the degree of the numerator is greater than the degree of the denominator. So we know that we will have a slant asymptote, and what it says at y equals mx plus b, where mx plus b is the quotient of the rational function when long division is carried out. So we're going to do some long division here. We have to divide 4x plus 4 into x squared plus x minus 2. So all we're doing here is taking our function, which is a division problem, and actually doing the dividing. So 4x into x squared is 1/4 x. We think what times 4x gives me x squared, so that's 1/4 x. So we multiply, which is x squared plus x. It's multiplying this times both of those, and then we subtract. When we subtract, actually everything becomes 0. That doesn't always happen. Then we bring down the -2. 4x doesn't go into -2 because -2 does not have a variable. So we could put plus 0 here, which is 0. We subtract and get -2, and so we have a remainder of -2, or we have plus -2 over what we were dividing by. Now what happens here is this is the quotient. This is our answer to the division problem. But we're just looking for this first part, mx plus b. So our slant asymptote is y equals 1/4 x plus 0. What happens here is as x gets larger, this gets closer and closer to 0. So our graph is getting closer and closer to this line, but it never reaches it because it's always a little bit away as x gets larger. So our takeaway there is our slant asymptote is 1/4 x plus 0. So we're going to graph that. That's a line. It goes through a y-intercept of 0 and a slope of 1/4. So up 1/4, up 1/4, or down 1 left 4. And so we can draw in this slant asymptote. And now we're going to look for any other important points. If we can find the y-intercept, we do that. The y-intercept is when you plug in 0 for x. So if you plug in 0 for x, this term's gone, this term's gone, and this term's gone, so you have -2/4. So our y-intercept is y equals -2/4, which is -1/2. So we're going to put our y-intercept here at -1/2. And that should be enough for us to graph our function. So here's what we do. I'm going to look at to the right of my vertical asymptote, and I really have two choices. I could either come down and try to have this orange part. Well, to do that, I would have to cross through the y-axis to get to my the x-axis to get that y-intercept, and that can't happen because there's only zeros at -2 and 1, which means my graph must come up. So I'll do the graph in orange here. It has to come up, go through this y-intercept, go through the 0, and then get closer and closer to this slant asymptote. And then on the other side, we can think about two different things. We know this asymptote here had multiplicity 1, which means the graph goes in opposite directions on the left and right side of the asymptote. So in this case, on the right side, it's going down, so the left side has to go up. And so it has to come down and go through that. And then it gets closer and closer to our line here. I'm going to redraw this other side. I was supposed to still be there. The right side might have been better to try to have this come up like this. Probably gets closer to that asymptote like that. I drew that incorrectly to start with. So I'm going to erase this part. And so there is a sketch of that graph.